What if you could build a machine smart enough to solve cancer, reverse climate change, and unlock the secrets of the universe? The Thinking Game is not just a documentary, it is a front row seat to the most dangerous and thrilling scientific adventure of our time, the quest to solve intelligence itself. 1. The boy who wanted to solve intelligence. The story begins with a young prodigy, Demis Hassabis, a chess champion who realized early on that the human brain was the most powerful machine in the universe. While the world marveled at IBM's Deep Blue beating Garry Kasparov, teenage Demis saw its flaw. It was brute force, not true intelligence. He dreamt of something greater, artificial general intelligence, a machine that could learn and think like a human, but infinitely better. From coding hit video games like Theme Park at 17 to studying neuroscience at Cambridge, every step of his life was a calculated move towards one goal: founding DeepMind. In a tiny London office, he gathered a team of dreamers and pitched a mission that sounded insane to investors. We will solve intelligence and then use it to solve everything else. 2. The move that shocked the world. The documentary vividly captures the tension of the 2016 AlphaGo match in Seoul. This was the Sputnik moment for AI. Go, an ancient board game with more possible moves than atoms in the universe, was supposed to be impossible for computers to master. Yet, we witnessed the chilling moment AlphaGo plays Move 37, a move so creative and alien that no human would ever play it. We see the devastation of Lee Sedol, the human champion, representing humanity's last stand. But through Demis's eyes, we see hope. This wasn't the end of human creativity, it was an expansion of it. The film brilliantly portrays this not as man versus machine, but man creating a new kind of fire. 3. Decoding the building blocks of life. Critics asked, so what if it can play games? Demis's answer was AlphaFold. The film takes us into the high-stakes world of the CASP competition, the Olympics of biology. For 50 years, scientists struggled to predict how proteins fold, a key to understanding life and curing diseases. The DeepMind team, exhausted and working remotely during the COVID-19 lockdown, faced immense pressure. The documentary captures the raw emotion of their breakthrough. AlphaFold didn't just compete, it solved the problem entirely. In one stroke, they released the structures of 200 million proteins to the world for free, accelerating drug discovery by decades. It was a gift to humanity, proving AI could be a tool for radical good. 4. The Oppenheimer moment. As the film draws to a close, the tone shifts from celebration to caution. Demis compares the dawn of AGI to the Manhattan Project. We see intimate moments of him conversing with his AI, which describes Michelangelo's The Creation of Adam with haunting poeticism. The documentary leaves us with a profound realization. We are building entities that might one day surpass us. Demis warns that while AI can save the world, it also carries the risk of uncontrollable power. The film ends not with an answer, but a challenge. We are handing the torch to a new intelligence. Will we guide it towards light or darkness? From mastering games to mastering biology, DeepMind's journey is a blueprint for our future. Now, let's use NotebookLM to decode the complex science behind AlphaFold and analyze the ethical safety manuals these modern-day Prometheans are writing for us.
All right, today we're going to talk about the story of DeepMind, this incredible AI lab. We're looking at it through the lens of the documentary The Thinking Game, and really it's a story about a massive quest to figure out intelligence itself, and it all kicks off with a pretty wild question.
Seriously, think about that. How did mastering old Atari games and an ancient board game lead to one of the biggest scientific breakthroughs of our time? It sounds like something out of a movie, right? But it's exactly what happened. And to get how they did it, you first have to understand just how massive the problem was that they solved.
So, to really get a feel for the scale of this whole thing, we're actually going to start at the end, with the jaw-dropping scientific breakthrough that all this work was leading up to. Okay, for 50 years, predicting how proteins fold themselves into these super complex 3D shapes was like the holy grail of biology. It was so huge that in 2024, the guys who created it, Demis Hassabis and John Jumper, got the Nobel Prize. But this win didn't just appear out of nowhere. Nope, it was the result of one person's lifelong obsession.
So who's the mastermind behind this? To really understand the victory, we have to understand the guy with the vision.
Demis Hassabis has, well, a pretty unique resume. He was a chess prodigy who was obsessed with just thinking about thinking. Then he becomes a video game designer, literally building entire worlds from scratch. And then he becomes a neuroscientist, studying the only proof of general intelligence we've got, the human brain. You see how these three things, games, neuroscience, and strategy, all came together in 2010 when he founded DeepMind.
And right from the very beginning, the mission was just crystal clear. The goal wasn't just to make some clever programs. No way. It was to solve intelligence itself, to build what's called artificial general intelligence, or AGI, and then point that intelligence at humanity's biggest, toughest problems. So, how do you even begin to teach a machine how to think?
Well, DeepMind's answer was, believe it or not, pretty playful. They figured that games, everything from the simplest arcade classics to the most complicated board games in history, were the perfect sandbox to teach an AI how to learn, totally from scratch.
The process was actually brilliant in its simplicity. They didn't tell the AI the rules of the game. They just showed it the screen, the same pixels you and I would see, and gave it one single instruction. Get the highest score you can. It learned through something called reinforcement learning, which is basically just millions of attempts of trial and error, getting a tiny reward for a good move. And it taught itself. In the game Breakout, it got so good it figured out the best strategy was the tunnel behind the bricks, a move that totally blew away its own creators.
So after crushing Atari games, DeepMind looked for a much, much bigger challenge, the ancient game of Go. And just look at that quote. The complexity is just astronomical. We're not talking about simple reflexes here. This is about intuition, deep strategy, pattern recognition, things we thought were uniquely human. That match in 2016, it was a genuine historical moment. The whole world watched as AlphaGo beat the legend Lee Sedol. But it wasn't just that it won, it was how. It made moves that were described as creative, even beautiful. There was this one, move 37, that was so bizarre, so against centuries of human strategy that everyone thought it was a mistake. It wasn't. It was a completely new idea, born from a non-human mind. And the impact was immediate. It was global. For the whole world, but especially for countries like China, this was a massive wake-up call. The AI race wasn't just some academic thing anymore. It was now a matter of global importance. But then came the next crucial leap. See, AlphaGo learned by studying games played by human masters, but its successor, AlphaZero, it started with nothing, just the rules. By playing against itself over and over, it surpassed thousands of years of human knowledge in a matter of days. It discovered strategies no human had ever even dreamed of.
And that ability, to find brand new solutions in a massive sea of possibilities, to learn from square one and go beyond what we already know, that was the key. The team was finally ready to move past the perfect world of a game board and aim their creation at that messy, 50-year-old mystery in biology.
So what exactly is this protein folding problem? Well, think of proteins as these tiny machines that run literally everything in our bodies. Their job is determined by their unique 3D shape. We know the blueprint, the amino acid sequence, but figuring out the final folded shape from that blueprint is insanely difficult. Solving it is like finding a master key for designing new drugs and understanding diseases like Alzheimer's. The result was just staggering. AlphaFold didn't just solve the problem, it completely obliterated it. In a super short time, it predicted the structures of over 200 million proteins. That's pretty much every known protein on Earth. And then, DeepMind gave the entire database to the world, for free. It's speeding up biological research in ways we're probably just starting to understand. But, an achievement this huge doesn't just answer questions. It raises a whole bunch of new ones about our future and about the incredible power of the technology we've just created. So the documentary, The Thinking Game, is very celebratory. It focuses on AI as this amazing tool for good. Critics, on the other hand, said that while it's easy to understand, it kind of feels like a sales pitch for AI. And of course, a lot of viewers brought up really important concerns about who governs this stuff, and how we stop it from being misused.
Because we have to remember, the ultimate goal here has always been AGI. Not an AI that's good at one thing, like playing Go or folding proteins, but one that can learn to solve any problem. A general-purpose problem solver that could change science, medicine, pretty much everything.
And the film leaves us with this really powerful thought. Just like the invention of fire or electricity completely reshaped human life, the arrival of a true AGI could be another one of those fundamental turning points for our species. The one question it doesn't answer is, what exactly is that world after AGI going to look like?